Hi all, my name is Anil. In this video, I'll talk about AttrFusedNet. Most of the state of the art in pedestrian analysis assumes access to the versional data, which poses a serious risk to individual privacy, and it may depreciate the existing research usability due to privacy data regulations like GDPR. Compared to the traditional privacy preserving methods such as blurring and pixelation, visual abstraction method offers an enhanced privacy by replacing visual appearance information with a wireframe. If you look into the multi-pedestrian tracking, which typically involves three stages: detection followed by feature extraction followed by track association, where privacy invasive methodologies are used to calculate the features of pedestrians, which are used to associate the tracks between the pedestrians. However, the wireframe representation completely removes all the pedestrian appearance information, which resulting reduced performance on current state-of-the-art pedestrian tracking algorithms such as deep sort and strong sort. AttrFusedNet is proposed to improve the tracking association by generating the combined embeddings of pedestrians and attributes. It utilizes a multi-head cross-attention between the wireframe representation and attribute metadata representation. For a given image, we calculate the wireframe along with the attributes. We use a multi-head cross-attention to combine both the features of wireframe and metadata. The proposed network consists of two blocks, feature encoding blocks and fusion blocks. Feature encoding blocks are used to calculate the separate embeddings for both wireframe and metadata, where fusion block is to fuse these features together using multi-head cross-attention. To test the proposed method, we generate a privacy enhanced dataset of mod 16 using a pair and STTN. AttrFusedNet is used to generate a metadata for each pedestrian. As depicted in the figure, each AttrFusedNet is used to generate a metadata for each pedestrian. As depicted in the figure, AttrNet will give a set of attributes for a given pedestrian image. Following are the examples of the wireframes generated for the version image from our 16 dataset. We use the deep sort to study the effectiveness of the proposed method, which initially we test the deep sort with the versional images. Then we use the wireframes with a deep sort to test the performance of the versional algorithm with the privacy enhanced images. You can see the number of ID switches reduced, number of ID switches. You can see number of ID switches increased. Then we use the attribute fusion. Then we use the attribute fusion with the wireframes. We use the deep sort to study the effectiveness of the proposed method. Initially, we use the deep sort to study the effectiveness. We use the deep sort to study the effectiveness of the proposed method. Proposed method is able to improve the tracking performance by reducing ID switches by 40% compared to the privacy enhanced data without attribute fusion. As you can see, first we tested the deep sort with the versional image. These are the metrics we get, where the ID switches are 434. When we tested the same algorithm with the privacy enhanced dataset, which is wireframes, we can see the tracking performance, which means ID switches are greatly improved. We use the deep sort to study the effectiveness of the proposed method. Proposed method is able to improve the tracking performance by reducing the ID switches by 40%. Compared to the deep sort and wide frames, we can see the AttrFusedNet able to improve the number of ID switches by 40%. Thank you for watching.